Hello folks, I wanted to go over the final, excuse me, I want to go over the final for blueprint reading with you guys real quickly. To check the squareness of a building, so we know that a triangle is 3, 4, 5. We can take any number and multiply it by 3, by 4, and by 5 and get any combination. So the only one that fits here would be 6, 8, 10, which 3 times 2 is 6, 4 times 2 is 8, and 5 times 2 is 10. So that was the correct answer there. Why are septic lines typically sloped 1/4 per foot? That is so that the water does not outrun the waste. Okay, if it's any steeper, the water will outrun the waste. If it's any less, more flatter, then the water will not have force enough to push the waste on down. A septic tank is set dead level. Okay, it's not angled in any way, shape, or form. It's set dead level, and then when the intake is approximately 1 to 2 inches above the output. So water comes in first and then fills up and will leave out so that it doesn't run back. As a rule of thumb, a footing size is based on its thickness of foundation. So we talked about this, and I explained that if a foundation wall is 8 inches, then the footing is going to be typically 8 inches deep and 16 inches wide. Now that does change with multiple heights, but as a rule of thumb, that's where we can start. Why do houses have thicker walls behind a bathroom? That is because that in a toilet, the vent stack going out through the roof is typically 3 inches, and we have to widen that wall so that we can enclose the plumbing. What is the total rise of a slope 512 and a run of 14 feet? So to do that, basically it's 5 divided by 12 times 14 gives us 5.8333, which is 5 foot 10 inches. How many cubic yards of concrete are required for the lower level slab of the inside the wall? So let's go over to here where I've drawn this out. So this is basically inside the walls. All right, so it goes around the outside here. Just inside the crawl space is counted because it does say concrete floor there. Just figure it up under the chimney there and the steps, but you must add this little triangle area, and you must add under the doors here. So these doors are 6 foot wide, and you can find that out by looking over at the window detail. And I did say they were a door, but these are sliding glass doors and are bought from a window company. So a lot of times they put the sliding glass doors on a window schedule. So this wall and this wall both are 5.5 inches. So 5.5 inches times 6 feet times 2 will give you 5.5 square feet of surface there that must be poured. The triangle here is basically you take, let me go back over here to this so you can see this. Pull it up. Come on, there we go. All right, so we have 3'6" here. This is a 45-degree angle, so 3'6" times 3'6" divided by 2, because it is a triangle, will give you 45 square feet. This little area right here is found way over here, 1310 pull this down through there, and you have approximately 6 inches there. If you do the math, 14.1 subtract 13.9, you will find out that there is 6 inches difference here. Okay, so we can take 13.10, subtract 6 inches here, subtract 2 inches here, and that will give us 13.2. 13.2 times 13.9, and 13.9 I got from the 13.9 here, and that is actually wrong. So it's not 13.9, so I've got to take 10 inches away from that. So 13.9 take away 10 will be 12.11. So this is actually 12.11 here. So this number here is going to be a little bit different. And then this whole area here, right through the green line there, is 226.75 square feet. This is going to be a little bit less than 181. So we add all those together, and let me go ahead and redo this one right quick. So, excuse me, 13.75 less 0.8333, which is 10 inches, gives me that 12'11", and I'm going to multiply that by 13.1666667 equals 170.06. So that changes that right there a little bit. So let's just do that. We'll scratch that out, and then put in the correct one here. There we go. All right, so I'm going to start adding up my square footage here. Plus 726.75 173611, good enough, plus 4.5 down here at the bottom, plus 5.5, whoops, here for the doors, and that equals 906. This will be square feet, so I'm going to multiply that times 4 inches, 0.333333 equals 302.27 cubic feet. So to get that over to cubic yards, I'm going to divide by 27, and that gives me 11.19 or 11.2. So I can go back over here and put in 11.2. Whoops, 11.2. Okay, number 8, according to R403.1.6, anchor bolts in the state of North Carolina shall be. So let's go over here to the International Code Council, iccsafe.org. I'm going to go into online building codes, and then I'm going to click on the state and click on North Kakalaki, and then I'm going to wait for it to come up. Why is it not coming up? Codes. Well, I was just in here a minute ago. Let's try this again. Click on map. Click on North Carolina. Well, I was just there. I don't know why it's not going to come up now. Oh, free trial. No, it's not it either. Hang on, let me pause this and find out what's happened here. Okay, I'm not really sure what happened, but I went back and opened it and closed it several times, and finally it showed up. Maybe I just didn't give it time for it to pop up. But anyway, so I just hit, the state of North Carolina on that map, and it pulled up all of these here, and we want residential. This is 2018, so I'm going to try, and it says current adoption, but that is not true. We have not adopted 2018 yet. So I'm going to go back to 2012, and that is just going to keep popping up, isn't it? Let's see here, what else we got. Nothing. This is making me mad. Oh, there we go. All right, so free view on the 2012 Residential Building Code. Jesus, Pete, I don't know why it's taking us so long. They change that thing ever so often, and it's just, I don't know, it gets worse every time. So I'm going to hit Control F, and that brings up a find. Maybe it's not. Maybe they've turned it off. No, my computer has locked up. For God's sakes. All right, so now find is up. Jeez. So I'm just going to highlight this, copy it, paste it, and then it's going to give me several different things here. And I'm just going to go until I find R403.1.6 Foundation Anchorage, and it talks about that the sole plate and shall be a minimum of 2 bolts per plate section, yada yada yada. If you keep on going down through here, you will find that bolts shall be at least a ½ inch in diameter and shall extend a minimum of 7 inches into the concrete or masonry. So if it's sitting 7 inches into it, you got an 1.5 inch mud seal on it. That would be 8.5 inches, and then you got to have some on top of that. So all in all, 12 inches is the only bolt that's going to be sold. So our choices are 1/2 by 12 at 4 inches on center, or 4 feet on center, or 1/2 and 12 at 6 foot on center. If we go back over here and do a little bit further reading, you will find out that the maximum spacing shall be 6 foot on center. So this is the one that we want there. Okay, anchor bolts in wood, in the wood seal are, and I apologize here because this question is talking about the plans. So if we go over to the plans and we look at the anchor bolt here, we'll see a 3/8 by 1/2 inch or 3/8 by 12 inch anchor bolt at 6 foot on center. So that is the one here. All right, now remember that we couldn't do this in North Carolina under the current building code because it is 3/8 and not half. So make sure that you understand the differences in that. So, and again, that's my fault according to North Carolina, according to the plan. So stair stringers between the decks, what size are they? We're going to go right down here to the framing, to the floor framing, and we see that they are 2 by 12 stringers at 24 inches on center, 2 by 12. Subfloor in the bathrooms. So we go back over to the typical section, and we're going to see that we have 3/4 inch tongue and groove plywood. That is throughout the house. That nothing changes there when you see typical. All right, so it's going to be 3/4 tongue and groove plywood. What is used at the top course of the foundation at the heat sink? This one was a little hard to find. I think some of you guys had some problems with that, and I hope that I helped you out with on the little video beforehand. But if you go right here and look at this, you'll see that this is the heat sink, and we have some sections going through the heat sink here. And so we can look down on these sections, and I forgot to look at what number it was, 4, 7, and 2, 5. So let's go to 2, 5 first. 2, 5 is in here. We don't have a wall, so it really doesn't show anything. What was that other one that I said? Something 6. 4, 7. So we'll go down here to 4, 7. 4, 7. 4, 7 is this one here. That's not it. So, oh, here. So even though this is the deck detail, here is the heat sink, And you'll see that the top course on this wall here is a 6-inch CMU. So 6-inch CMU is your correct answer there. What is the vapor barrier under the concrete slab? We can go back to our section here. And we're going to look here at a 6mm poly vapor barrier underneath the concrete. 6mm poly. What are the rafter headers at the skylight? So the skylight's kind of hard to find if you're not really looking for it very good. The skylight is right here and right here. So let's go down to the framing, the roof framing, and we see the skylight here. Well, the skylight has some funky stuff going on here, and it's in a roof that has 1 3/4 by 9.5 inch TJIs at 16 inches on center. So let's see if we have any details anywhere about the skylight. And sure enough, right here is the skylight detail, and it says that we have TJI joists here, but it doesn't give a size. However, we just got through talking about that these were 9 and whatever I said, 9.5 or 9 1/4. Let's go back and look at that. Sorry, right there, 9.5 TJIs. So we're going to have 2 9.5 TJIs at that point. What is the finished material on the east side of the playroom? So let's go back over to we'll look at our plan first. We got the playroom down here, and you'll notice that it says 1/2 inch gyp board right there on the playroom. So that is going to be our choice, 1/2 inch gyp board. What is the material used for the window casing interior? I've had a couple of people looking at the doors. Here's the door types, all right, and here are the windows. So this is outside, this is inside, and we don't have any casing in here. So the casing itself is 1/2 inch gyp board. Okay. What is used at the expansion joint at the edge of the heat sink? Well, if we go back and look at that one little heat sink that we see, that one little thing down here, where we have that top block there, and then we have the 4-inch concrete slab here, you'll find that we have a 1/2 inch rigid insulation separating those two. So that would be used as the expansion joint for the heat sink. The reason that it is insulation, because it is a heat sink. So we're trying to make that as insulated as possible. What is used for the exterior wall studs? Right there it is, 2x6 studs, 24 inches on center. If you go back over to the typical section, you will find the very same thing, 2x6s at 24 inches on center. What is used for the standing seam? What is used to support the standing seam roof? Pick all that apply. Now here's your choices, and I know when this test was first posted, a couple of these answers were wrong, and I do apologize for that. So let's go back over here and find the standing seam detail on here. And let's see, should be one more. Standing seam detail. Here is the roof detail. We have standing seam roof here. And what is supporting it would be 1x4 stripping staggered to allow airflow. All right, so there's one. 1x4s at 4 inches on, or 4 feet on center. And then other choices that we have are 2x10s at 16. These are not. These are 1 3/4 by 9.5 inch TJIs. So is that a choice in here? It sure is. It's right there. Do we have 2x6s at 24 inches on center? No, we do not, except for, on the wall, but that's not really holding. I mean, it is holding the roof, but it's not actually holding the standing seam roof up. And we don't have any 2x10s. So that's the end of that question right there. What is used for the seal plate? Let's go back over to the general, and I've locked it up, haven't I? Not responding. Give it a second. I done forgot question. What's used for seal plate? So we go down through here, and we have a 2x6 seal plate. So here's a 2x6 seal plate. Here's a 2x6 pressure treated seal plate. Either one of these will work. I really should go back through there and give you credit if you put pressure treated, even though the plan is not pressure treated. In the state of North Carolina, we've got to have pressure treated. However, remember that in the state of North Carolina, we have to meet this wall thickness, and this particular wall thickness is either 8 inches around the garage or 10 inches around the house. So this would have to be either a 2x8 around the garage or a 2x10 around the house. What material is used for the base plate on the post supporting the LVLs? A lot of you keep forgetting that there is a 3D isometric view of these that cage that's in the middle of it, and right there you will see base plate 8x8 by half typical, so 8x8 by half-inch steel. What material is used for the drain field? We find that on the plot plan or the site plan. And come right up here, and we have 4-inch, and if you guys were really paying attention, we have 4-inch schedule 40 here, but we have 4-inch here. It's not going to always be the same. We have perforated pipe. If you remember when I talked to you, the perforated pipe allows for the sewage or black water to perk into the ground. Any of these others would not be a good choice, even though they may be PVC or ABS. We do not know. It doesn't specify which type or which material. It just says 4-inch, but we do know that they should be perforated. Sometimes on a plan, we are expected to know how it's built so that we know which material to put in there. It's not always going to call it out, so be aware of that. What material is used for the hip rafter in the northeast corner of the house? Let's go over to the roof framing plan. And go back and read this again. The northeast corner, so this is north, this is east, this is the hip rafter. We have 1 3/4 by 11 7/8. What material is used for the reinforcement in the concrete slabs? So let's go over to our typical wall section. Pull into here. We have a 4-inch concrete slab with 6x6, 10-10 woven wire mesh. Bam. Number 25. What material is used for the reinforcement in the footings? Footings. Okay? Not the footings to the wall, but in the footings. That's the big key word there, in the footings. If you look down here in these footings, and with this note, it tells us we have 8 by 16 or 10 by 20 concrete footings with 2 number 4 rebars. Some of you wanted to count that dowel right there, but the dowel is holding the wall to the footing. It really does not have any strength for the footing itself. So 2 number 4 rebars. What material is used for the roof deck? All right, so the roof deck is here, have the standing seam metal. We have an ice shield, and then we have 7/16 OSB sheathing there. So that would be 7/16 OSB. That would be the roof deck. What material is used for the roof insulation? Let's see, do we have it here? Yes, we do. R30 batt insulation. That is this here. Follow the arrow. R30 batt. What material is used for the rungs in the ladder of the loft? Here's another one that takes you a little bit. Here's the railing here's the loft rather, here's the railing. What about the ladder? Well, somewhere there's going to be a picture of the, and I've locked it up again. Let that settle for just a second. There's going to be the railing, and this is here, the railing and the ladder detail. So the question is, what material is used for the rungs to the ladder? This is the handrail, this is the ladder, these are the rungs, and it is a 1 1/4 inch diameter steel pipe. 1 1/4 inch diameter steel pipe. What material is used for the stair treads inside the house? So let's find our stair detail here. And it tells us that we have 5 1/4 inch oak tread wedge and glue. So we have 5 1/4 inch oak. 5 1/4 inch oak. What material is used girder under the west? What material is used for the girder is what that's supposed to say. What material is used for the girder under the west wall, under the west wall, under the bedroom 1. Okay, so let's back out here for a minute and find bedroom 1. Here's bedroom 1. And the west wall, this wall here. So let's go down to our section here, and we find bedroom 1. And here is the west wall, and we have that channel that we've seen so many times before. Now we're going to get into a little bit of math. So how many linear feet of 2x10 lumber in the lower eave of the corrugated roof will be needed to be ordered? All right, so let's back off and look at something. Here is the corrugated roof. It is a translucent corrugated fiberglass roof. I know a lot of you are looking to expect to see steel, but this is the translucent corrugated roof. This is the kitchen here. This is the garage here, and this is that deck that separates the two. So if we go up to our deck here, this is the deck, and this is where the corrugated roofing is. So we're going to have an eave that runs across through here, and you can say 511, 511, 511, or you can say 13.9 plus 4. Let's make sure that those two work out together. So let's just do this easy way. 11 divided by 12 plus 5 equals times 3. That is 17.5. 17.25 rather. So that's 17 feet and 9 inches. So 13, 14, 15, 16, 17, 17.75 is the correct answer on that. Now, let's see how many 2x10s that we have there. So let's go see if we can find this eave. So it's talking about here 7, 7. So let's go find 7, 7. Page 7, 7, 7. Here's our eave. Okay. So how many 2x10s do we have there? We have 1, 2, 3 that make up this entire eave. Okay, so let's go back over here to our number. We had 17.75 times 3 equals 53.25 is going to be our correct answer there. That's how many that we've got to order. Excuse me just 1 minute. Okay, sorry about that. How many total linear feet of soldier course bricks are there in the fireplace? So let's go over to the fireplace plan. Now let's look at this very closely. Here is our fireplace, and we have a soldier course here, we have a soldier course here, and we have a soldier course here. Now look here. This soldier course is holding up this platform here, and there's granite on it, granite on 3/4 inch plywood. So we actually have this soldier course going not just in the front, but, and if you look right up here, some of you had a hard time finding this. So if you look right here, this goes all the way around. That soldier course goes all the way around to hold up that granite. Okay, so we're going to have 7 feet here. And we're going to add to that 3.333333 equals 10.333. Now let's look at something here. 10.333, there's that right there, and that's what I ordered there. So that's what number we have here, but I've got another 2 sides to this. So I can take this and multiply it by 2. Now that 20.666 goes all the way around it. Okay, so we've got that much of it. Now we need to do this 2 foot and this 2.8. Let's add that to it. Plus 2 plus 2.6666667. That gives me a total of 25.333. I'll go in here and add that in. Okay, 25.333. What is the length of the joists in the loft in feet? So let's go back over to our set of plans. Go look at the loft. Here's our loft. So our loft is 7 feet from end to end. We do not count these open spaces. That's open, just like it means. So we need to find out how these joists are going. So let's go down and find our loft here on the framing plan, and we have a loft here, and the loft, all of these are going to go from here to there, which we said was 7 feet, right? However, we have, and look, these arrows going down through here, we have not 1 but 2 LVL beams on this side and 2 LVL beams on this side. So let's play the math here. 1.75 plus 1.75 equals 3.5 inches. All right, so we have 3.5 inches on either side. So we multiply that times 2. And now we have 7 divided by 12 to put that into feet. Now we're going to subtract that. We're going to subtract that from 7 feet to end up with not that. How did I do that? So I had 7 inches divided by 12, and I'm going to make that a negative number, and I'm going to add to it 7. All right, so now I end up with 6.41666667. Okay, so that is going to be, I got to think about it, 5 inches. So 6 feet 5 inches. And I'm going to go put that number in here. Okay. What is the depth of the earth fill over the septic tank? Let's go over to our plans. Go way up top. Too far. And find our little detail here of our tile field, and we have earth backfill here with 6 inches over top of it. And this is in inches. Remember not to put your inch or feet marks. What is the distance from the outside surface of the foundation under the dining room to the center line of the southern deck? 8-inch diameter concrete footing in feet. That's a mouthful. A couple of you had some problems with this. It's understandable. So it's talking about the southern decks. These are the southern decks here. All right, so our dining room is here, And this is our sunken floor here, sunken living room here, dining room. So this measurement is coming off from here and going to here. We're looking at 12 foot 8 all the way to the outside face of the deck. And then we're going to come back 1 foot. So our answer is going to be 11.666667 because we have 8 inches there. All right, what is the length of the 2x4 studs under the living room bench in inches? This one was a real fun one. I know a lot of you guys probably cuss me to death, but look right here at your little bench detail. And what I'm asking for, and I think I told you on the little helpful, the help video, is I wanted that measurement right there. And I wanted it in inches. So let's pull up the handy dandy calculator here. And I've got 1 foot 4 inches. So that's 12 plus 4, just so that we can make it simple, at 16 inches. We have a 1/2 inch of AC plywood, so I'm going to subtract 0.5. I have, we don't take away this molding. This molding is on the same plane as the plywood. And then we have 2x4 here, but we're talking about the 3.5 inch distance. So I'm going to subtract 3.5. And then I have 1.5, and 1.5 is 3, plus 1.5 down here, which makes 4.5. So I'm going to subtract 4.5 inches to end up with this little piece right here being, I need to cut me a whole bunch of these that's 7.5 inches long. It's going in there. 7.5. What is the length of the C8 by 11.5? It's supposed to be 11.5 steel beam in inches. So if we go back over to our plan, look at that, remember that isometric that we've been discussing and fussing about? So that's where it's going. It goes from this corner of the post, from the inside corner of the post to the inside corner of the post. This is the north, so that is the east side. We've already discussed that. So let's go back up here to our plan. And the beam is going here. And there's a column here, and there's a column here. And that is 1310. The columns, excuse me, are 3.5 inches. So we want to take half of 3.5 here and half of 3.5 here. And then we're going to add it. And then, so we're basically going to take 3.5 away from 1310. Excuse me. So we have 13.83333333, and we're going to subtract 0.25, which is 3 inches. And I'm going to have to memory clear plus, and so I'm going to say 0.5 divided by 12, and I'm going to subtract that from it and end up with 13.54166666. Yep. So we'll go in there and put that in. That's how long that beam's going to be cut. What is the length of the steel dowels that anchor the foundation wall to the footings in inches? Back over to the plans, going to the wall section right down here. Here's those dowels that we've been talking about. Number 4 by 8 inch dowels at 3 foot. And that's supposed to be on center. There's supposed to be an on center here. So number 4's at 8 inches dowels at 3 foot on center. So the dowels themselves are 8 inches. Oop, wrong one. What is the length of the studs in the wall separating the playroom from the crawl space under the kitchen in inches? So let's go right over here. And here is this crawl space wall. Something I want to bring to your attention is this is 9.5, and this is 3/4 inch tongue groove plywood. I want to show you a little trick. So 9.5 plus 0.75 equals 10.25 inches. Is that correct? Yes. I'm going to do it again. Just 9.5 plus 0.75 equals 10.25. Look at this. Obviously, the oh, well, I'm sorry. So this is the TJI plus 1.5 inches down here. So let's clear that and say 9.5 plus 1.5. Bam, 11 inches. So that's still wrong. All right, so I don't know where they come up with that. So we don't go by that one. We're going to go by this 5 foot over here. And let's see, are we asking for feet or inches? We are asking for in inches. So let's go ahead and just put this 5 foot in inches. So 5 times 12, bam, 60 inches. That's 60 inches here. I'm going to take away 0.75 for the flooring, the subflooring. I'm going to subtract 9.5 for the TJIs. And then I have 1.5, 1.5, 1.5 is 4.5. Subtract 4.5 inches, and I have 45.25 inches that this is going to be cut. So I'm going to have to cut a whole bunch of these to make this wall here. Number 40. What is the measurement from the finished floor to the top surface of the freestanding closet cabinet unit in the kitchen? Include surface material in inches. All right, so in this same view, what I'm asking for is I'm asking from here to there. All right, so I have 7 feet, and then I have 1/2 inch gyp board on the top, I have a 1/2 inch gyp board on the bottom, and I have a 2x4 in between it here. So let's pull out the calculator, and this is supposed to be in inches again. All right, so pull out the calculator. 7 times 12. That gives me 84 inches from there to there. I'm going to add 1/2 inch for drywall under here. I'm going to add 3.5 inches for the studs that are in here, and then I'm going to add another 1/2 inch for the top piece of drywall here. So we end up with a total of 88.5 inches. What is the thickness of the concrete at the haunches in inches? So we go to the haunch detail, back up here at the beginning, haunch detail, and we're looking at 4 plus 4 is 8. What is the total thickness in inches of a typical exterior frame wall? Allow 1/2 inch for siding. So let's go find this typical. And so basically what I'm wanting to do is I'm wanting you to tell me how thick is the total wall inside to outside. Okay, so we'll start on the inside, clear it. We have a 1/2 inch of sheetrock, and then we have 2x6 studs at 24 inches on center, so that's plus 5.5. And we have a total of 6 inches so far. Then we have house wrap, which is paper thin. We have 7/16 OSB. So plus, we've got parentheses, plus parentheses 7 divided by 16, close parentheses, equals. So now we have 6 7/16 for the OSB, and then the vertical siding I said was 1/2 plus 0.5. So we have a total of 6.9375 inches in that wall. What is the width of the south end of the driveway pavement, even with the front of the garage? All right, so wrong one. Let's go to our site plan again. Pull in here. We are wanting, I'm asking for a measurement along this whole line here. So how big is this? Let's find out. This is the garage, and the garage is 13.9. Okay, so I have 13.9 plus 3 feet plus 17 feet. That gives me a total of 33 feet 9 inches from this point to that point. What is the width of the treads front to back, excluding the nose in the stairs from the kitchen to the bedroom level? We go to the stair detail, and we see that excluding this nose, they are 10 inches. When laying out for the lake house, what is the diagonal dimension of the garage in feet? All right, so when we're wanting to lay this out, one of the best ways, if I can get to it, one of the best ways to lay this out square and even golly, I get to coughing, is to do a measurement diagonally from one corner to the other. And how do we find that out? So we have 24 inches on the long side here, or 24 feet on the long side, and we have 13.9 on the short side. So we could do it the hard way and do the square root of 13 feet 9 inch squared plus 24 feet squared. Let's see if we do it that way. Okay, so 13.75 squared, 24 squared, add that to it, and then I'm going to find the diagonal by taking the square root of that, so that is 27.6597. The septic tank would be okay to be placed as shown on the plan if the property setback is 12 feet. Yes or no? Is that true or false? So let's go over to the plans. We're going to see that this septic tank is set 10 feet from the property line, and the setback would be 12 feet. We cannot do that. Okay, we can't put anything in the setback, so this is false. So, hope you guys enjoyed it.